My name is Jen Aron. I'm speaking to you from Blue Raven Farm in Corbett, Oregon. I just want to take a moment to give a land acknowledgement and let everybody know that we are sitting on stolen land that rightfully belongs to Chinook, the Grand Ronde, Warm Spring tribes, as well as other indigenous communities that passed through, lived here. So I just want to take a second to pay homage to those communities. Thank you. So before starting Blue Raven Farm, just a little background on me. I managed a small organic farm in Portland, Oregon for 7 years. And we farmed by the book using annual tillage, following university guidelines on annual soil testing, tissue analysis, things like that. And really with every passing season, so for the first few years, things grew okay for us. But what I noticed around year 3 or 4 was that we started to see a decline in crop vigor and an increase in weeds, pests, diseases, and labor. And I had an opportunity to visit a lot of farms through the years and during that time. And I heard the same struggles from just about every grower that I visited and spoke with. So farmers everywhere were and are continue to struggle with weeds, pests, diseases, and labor. So it just felt like something was missing, and there was a missed opportunity to kind of tack back these ways that we had been taught to farm and do things differently. So in 2016, I started Blue Raven Farm in Corbett, Oregon, and basically have spent the last 7 years kind of unlearning everything that I learned my first 6 years of farming, and just trying to apply kind of some newer knowledge based on soil biology. My main goal here since we started was to put the health of our soil first and foremost with every decision. Every single decision, I'm asking myself, how is this going to affect our soil? So my goal today is to share with you just the last 6 years of this farming trial where soil has been at the forefront. And I just want to say there's just really not a one-size-fits-all approach to applying no-till methods or even soil health. We use so many different methods, and we trial and we have trials and errors and lots of tribulations, of course, along the way. But it's just about finding what works for you. So I just really want to take a moment that we have these best practices, and that we don't necessarily need to be rigid in one particular way, that oftentimes we need to bring in a lot of different modalities for it to be successful for our own site, because every soil is different, every climate is different. Of course, our climate is changing. And I just want to really be clear with that. So some of the things that I'm sharing today may work great for you, and some of them may not, or you're able to glean and take a little piece out of that and apply it to your own space. One thing that really seems to be a constant for us is that the less I disturb the soil, the better it is. And the better our crops grow, and the more biology I'm seeing come back to life and to start working for us. And I want to just also make sure that everybody knows that it takes time. So it's a really fun story to be able to tell. This is, we're 6 years, and I've been giving a talk very similar to this for the past year, and it's interesting to hear folks come through their first year of focusing on soil and say, wait, we still have weeds and we still have pests and we still have compaction. And I just want to say it now, and I'll say it at the end as well, that it takes time. it takes time. But you know, I think about these changes happening in like a geological time, right? Where we've damaged the soil for so many years, and soil's pretty forgiving overall for it to repair in, you know, a 3 to 5 year period. Okay, so this is where we started. This is one of our fields. We're a 5-acre farm. We have 1.5 acres in production, and we started with a pretty blank slate. This is kind of a nicer view. Our land, this land here was definitely full of burn piles and trash piles and so many weeds. Very few pollinators. It was rough. It definitely was not a farm, and I had a lot of folks scratching their head when they came out here, and I said, yeah, starting a farm out here. So this is kind of where we started back in 2016. In the fall of 2016, we came out, our soil was so compacted and so acidic, and you can see how just red and rough it was. I know that there may be some folks out there that are gasping, oh my gosh, it's a plow, that's so destructive. And yeah, you're not wrong. It is destructive, and I think of the plow, and this was the only pass of a plow that we did and have done on this land, but I think of it as like deep surgery, and it needed some repair, and opening things up like this in this very deep destructive way allowed us to get some organic matter back in here, correct some pH. Our pH was very low. It was like a 5.3 when we were here, when we first started. So I was able to apply agricultural lime and then seed 100 pounds of crimson clover. So in helping to increase organic matter in our soil. And like I mentioned, this piece of property was very devoid of pollinators, and this was a big beacon to bring those pollinators back, and it worked. It was pretty amazing. So on the left, you can see we allowed that crimson clover to flower, and we did do a final till, and this was our final till in the history of this farm. And to the right, you can see this is where we started. I created a raised bed, where like a permanent raised bed. So pulling dirt from the pathways and moving it into the bed so that we planted into that. And you can see how the soil is still, you know, definitely in the reddish color. So we're still in the early stages of repairing. Okay, so 2018, this was really our first full year in production. We were running a 40-person CSA and pulling about 80 pounds of salad mix that was sold for restaurants and chefs out of about half of an acre, just to give you a sense of the intensity that we're working at out here. The interesting thing about this picture is that, yeah, you kind of see a sea of green, but if you look over here, I don't know if you can see my cursor kind of circling around one of these beds here, that there's these patchy areas within this arugula strand. And this was the first sign of a disease called brassica downy mildew that spread through our farm like wildfire. You know, a lot of folks were questioning whether or not Blue Raven would have it easy, so to speak, because we broke ground and had a clean slate, so to speak, clean slate of weeds and pests and diseases. And gosh, like, I don't know where they came from, but they sure came out of everywhere. And I was a little shocked. I thought for sure I would get a freebie of a season, and that didn't happen. And it just kind of tacks back to soil health and repairing. So this is just all part of that journey. In 2000, and so also not only did that brassica downy mildew affect our arugula crop, but we had pretty substantial crop loss in kohlrabi and kale, broccoli. It affected cabbages, all of those types of crops, and it was very, very severe. Okay, so 2019, you can see that things are starting to improve. The soil still has a little bit of a reddish color, but it's starting to look a little bit more like a milk chocolate color instead of a caramely chocolate color. Things were growing pretty well. We were still struggling with the brassica downy mildew during 2019. We were struggling with diamondback moth infestations. We were struggling with marmorated stink bug infestations that were eating our tomatoes and peppers. And we were also struggling with a soil pest called the symphylan. And the symphylan is a microarthropod in the soil that studies are showing that its preferred food source is fungi. However, with most agricultural soils that have been tilled and abused, and herbicides and pesticides and things like that, the fungal networks are destroyed and disrupted, and so it's leaving those microarthropods without their preferred food choice, and so they in turn feed on baby roots, which is what happened to us in 2019. This was a pretty difficult growing season for us here. We had pretty substantial crop loss. But what we figured out was that if we can put a food source back in for the fungi, then perhaps we can get the symphylans in check. And that's exactly what happened. So this picture looks, everything looks pretty healthy, but it's a cool picture because it's in the springtime. These rows that you see with the lettuces and the fennels and the parsleys, there was almost complete crop loss. And this photo was taken in the fall. So repair and using biology to repair soils. And again, utilizing minimal tillage. So our solution, I went to a local composting yard and I picked out a compost, not wood chips. So I want to be really clear. It was actually a compost product, but it had visible kind of chunks and pieces of wood debris still present. And so woody debris is great fungal food. And we just basically scratched a wheelbarrow of this compost into the beds that were affected by the symphylans. And really within a few weeks, we started to see things turn around. So pretty remarkable. Okay. In 2020, this was kind of the year that things really started to turn around for us. This was 4 years in production, plus a year of planning. So I call it a 5-year trial at this point. You can see the peas to the left are overhead, super green, productive. I'm smiling. I'm happy with this. And while 2020 was just awful in so many ways with the pandemic, for the farm, it was really the year that things started to turn around for us in terms of soil health and getting good biology back into the soil. This bed to the right, this is spring of 2020, where symphylans the previous year had caused so much damage and death. And you can see how things are growing really healthy. So the symphylans are still present in the soil. They just have a food source within the soil that they're feeding on rather than eating our plant roots. Pretty amazing. Okay. Here's a handful of our soil. You can see it's gone from a reddish, rough looking color to a really beautiful dark chocolate brown. And, 7.5 billion soil organisms per handful of healthy soil is a modest estimate. I love the 7.5 billion because that's how many people are on the planet. So it really is a good way to kind of show just the intensity of how much life is in this soil. Okay, I know that some of this was already covered, so I'll go through this really quickly, but supporting soil microorganisms, so reducing soil disturbance. So that's going to be tillage. We'll talk about that just a little bit more in a little bit as well. Fertilizing responsibly, planting diversity. So with these microorganisms, they have such a unique synergistic relationship with each individual plant. It's a little bit mind-blowing that every plant has a relationship with a specific set of microorganisms in the soil. So the more plant diversity you have, the more potential diversity you have in these soil microbes. And then keeping plants growing at all times is key. We're going to talk more about that as well. Aiming for a minimum of 2% organic matter. How do you know how much organic matter you have in your soil? This is one of the things that just a traditional soil test will tell you. Like I said, minimum of 2% organic matter is key to help support microbiology in the soil. Here at Blue Raven, we started, I'm not 100%, but I feel like we were at about 4.5 or 5%, and now we're at 9% from compost applications and cover crops. So we've increased. Sources of organic matter include crop debris, plant roots, compost, and cover crops. Are there any questions at this point? Steph, any questions that you see out there?
Yeah, thanks for pausing, Jen. There are a couple questions here. So I guess there are 3, and I will go back to the earliest one. The question is, what food source was put back in for fungi?
Yeah, so it was that kind of a woodier compost that I used. And so what I mean by that is it's a compost that had gone through the full composting process, but still had visible, like small, maybe 1/2 inch to 1 inch small, like woody pieces that were still visible in that pile. And so woody debris is a really great source of fungal food.
Great. Okay, thank you. Another question, what was your compost application rate?
That's a good question. When we're talking about especially inoculating, so using a quality compost as a source for a food for microorganisms, it doesn't take much, right? They're teeny tiny, microscopic. So we were using, at this point, we were using about a wheelbarrow per 100-foot bed, and our bed width is 30 inches. That gives you a good sense.
Okay, a wheelbarrow.
We just it right into the surface.
Okay, could you just say that one more time? A wheelbarrow?
1 wheelbarrow per 100-foot linear feet.
Mm-hmm.
And our bed width is 30 inches.
Great, okay. And we'll just do one more here. I think there's a couple others that we can save to the end here. This one is just asking again what the food source was for the symphylins. What are they feeding on instead of the crop plants?
So the symphylins are feeding upon that wood source, that woody debris source from the compost.
Okay, thank you. Let me just do one more quick check here. maybe this is you're going to get to this, but the question is if you can talk about your process for bed preparation, weed management, and cover crop termination.
Yeah. Oh, great questions. I wish we had more time. Can we put a pin in those until the end?
Yep.
If we have some time,
Yep.
I'd be happy to go through it. It's a long answer, and I could probably spend 20 minutes of time going through that. So it's such a great question, though, and
yeah,
I would love to try to consolidate and try to answer it the best I can, maybe at the end, if that's
okay. Okay, we'll hold that one. Thanks.
All right, cool. Thank you.
Okay.
Great questions. Thank you. Okay, so I know that y'all went through this a little bit, and I kept it in here because I think that it's always good to hear things multiple times, and also maybe in a different way. Sometimes maybe a way that one person says something resonates in a way that something doesn't, and Steph did a great job. And so I feel a little shy about saying it again because she did such a good job, but here goes. So I think about soil microorganisms in the soil kind of as in two different categories. There's these decomposers and nutrient scavengers, and those are going to be the bacteria and the fungi. And then there's the soil predators, which are nematodes, amebes, protozoa, microarthropods. And those soil predators are essentially eating the nutrient-rich bacteria and fungi. And the bacteria and the fungi are so rich in nutrients that it's too much for the predators. So the predators excrete the excess in a plant available form. So this is, for lack of better words, this is called the poop loop, is one way that you can look at it. I tend to be more fond of just this idea of nutrient cycling. So here's some visuals. I'm not great at graphic design, but here's some slides to kind of put together what's happening in the soil in a visual, because we can't see these guys, right? They're too small. Most of these organisms are visible only with like a 400x total magnification. So just a review on photosynthesis, plants are converting sunlight and CO2 and converting it into simple sugars and carbohydrates. When the plant dies, here come the bacteria and the fungi, those decomposers, right? They're munching on that organic matter, that organic material, your crop, your flower, whatever it is. And then here come the soil predators, those nematodes, those protozoa that are then consuming the bacteria and the fungi. The predators then are excreting the excess in a plant available form for your next crop. So here it is, and again, in a deeper level of the soil, right? And this is super simplified, so bear with, but this is, gosh, in the years that I've been learning soil microbiology and my main goal is how do I explain this that A, is exciting, but is also applicable to farmers and growers, so that folks can really put to terms, into words, what we can't necessarily see is happening under the ground. So I'm trying to put a visual here, and it's simplified, I know. So bear with me. All right, so throughout the soil, we have sand, silt, and clay particles. That's your parent material, and it's all throughout the soil, but for simplicity's sake, I have it just down at the bottom of the screen. And we have the bacteria and the fungi that are excreting enzymes to break down those sand, silt, and clay and organic matter components, so that they can be reabsorbed into the bodies of the bacteria and the fungi. So here's what's really cool. So the plants are photosynthesizing, right? They're taking the sunlight and the CO2 and they're converting it into carbohydrates and simple sugars. But plants can't live on that alone, right? They need nitrogen, phosphorus, potassium, all these other things. So what the plants do is they excrete the really amazing, complex, and very specific combinations of sugars and carbohydrates and some proteins that are essentially a calling card for the specific microorganism that has the nutrient that it needs for when it needs it, whether the plant is fruiting or flowering, is, you know, what is it, spring, like whatever, you know, it's mind-boggling to me. We're talking like biologists are just now scratching the surface in this, but we're looking at perhaps millions and millions and millions of different combinations of these sugar carb complexes that are called exudates. And in turn, the bacteria and the fungi are attracted to those sugars and carbs. Aren't we all, right? Like, who doesn't love a sugar and a carb? So the plant is excreting these sugars and carbs. The microorganisms, the bacteria and the fungi are attracted to that food source. And so the bacteria and the fungi, they're continuing to reproduce and grow in populations right around this root system. But the nutrients that the bacteria and the fungi aren't available to them yet. We need to have the predators come through. So the predators are coming, attracted to the nutrient-rich food source of the bacteria and the fungi, and are eating that bacteria and the fungi and excreting the excess that they don't need in a plant available form. So that's just a quick little recap. I don't know if we need to recap it. I feel like I said it in a couple of different ways, but I'll leave this up here for just a second. And I don't know if there's any questions. Steph? Question?
Yeah, I was just checking. That was my delay. It was just,
I thought I lost you for a second.
I had to click back to unmute. No, I think we're good for now.
Okay, great.
Yep.
Okay, so this area that's right around the root system, this concentrated area of life, is called the rhizosphere. The rhizosphere. And what do you think happens to the rhizosphere when we run a tractor through with a plow or a tiller? It's hard to watch, right? We wipe out that life. Maybe not all of it, but quite a bit of it. Quite a bit of it. And what's really important to note is that this symbiotic relationship that I just described between plant and soil microorganisms has existed for millions of years. And so when this relationship is broken as a result of tillage, over fertilization, or pesticide use, plants have to rely on inputs from us, from the growers. And we do our best, but like, honestly, I feel like we're falling short more often than not, which is why we are finding so much pest and disease within our plants and within our farms. Our soil life is broken. This is a quote from the NRCS and USDA from a decade ago. Tilling the soil is the equivalent of an earthquake, hurricane, tornado, and forest fire occurring simultaneously to the world of soil organisms. So that gives you a little bit of a sense. Tillage is destroying soil structure, decreasing aggregates and macropores, which results in compacted soils. It's creating compaction zones in the soil that roots can't penetrate through. And tillage is speeding up the decomposition of soil organic matter carbon, which is then released back into the atmosphere as CO2. I just added these slides this morning. I'm kind of been geeking out a little bit. It's been fun to watch our soil evolve through the years. So this picture on the left, you notice that our soil is really, it looks kind of pebbly, right? There's a dime there for scale, but those aren't rocks, those are our soil. That's soil particles, so soil aggregates, right? Lots of particles that have been glued together by the microorganisms. That's what they do. That's what, that's part of what that bacteria and that fungi is doing in there. The picture on the left is kind of my new favorite thing to do. And it's essentially like taking one of these aggregates, right? An aggregate is a compilation of soil particles that have been glued together by microorganisms. And you can almost see like how much I'm actually pushing on that aggregate, that soil chunk. And what's so amazing to me about this is this, when we hear about tillage destroying soil structure, like that's what that is. That's what this is, right? This picture here of this soil glued so beautifully together. This is now soil that is more stable. It's more resistant to planting, to transplanting, to some tool usage, to rain, to all these things, right? And it's also like, it's kind of like a microbial mansion, right? It's a home to all of these microorganisms. So sorry to geek out on that for just a second, but I feel like there's so much talk these days about soil structure and tillage and, oh, you know, it's tillage destroys soil structure, but I think that that term can often get kind of diluted in our understanding of exactly what that is. Just to give you a sense of the scale that we're talking about with these microorganisms, this is 400 total 400x total magnification. The photo on the left, this is a little, I think it's a bacterial feeding nematode. My microscope skills are still very novice, but I'm learning. And this photo on the right is a beneficial fungi. And so I just got to say, you don't need a microscope to tell if you have healthy microorganisms or if you have microorganisms present in your soil. And beneficial microorganisms in your soil. Like your visual cues above ground are weeds, pests, and diseases. Because once we get the good biology working and back in your soil, then you're going to start to see those really start to decrease. So when I think the question arose earlier, like what do I do for weed management, or, you know, like the answer is we actually don't have any weed pressure anymore. We have some weeds, but they're not affecting our plants. And I have a photo so that you can see, but it's something that's taken some time to get there. Okay, so just to be really clear, but, you know, I tried to not to be super dogmatic about this term tillage. Like really any disturbance of the soil, I consider tillage. It's just a matter of what the degree of the tillage that you're utilizing is. So just really quick, plows and discs and tillers are inverting soil and are very destructive. So that's that hurricane and forest fire situation. The hoes and the harrows are moderately destructive, and just is going to depend on how deep and how vigorous the tools are used. Broad forks and spading forks are a hand tool and are pretty minimal disturbance. And as long as you're not flipping and inverting the soil, the disturbance, like I said, is pretty minimal. Hula hoe and the rake are hand tools, as you may know, and then the tilther is a very shallow mechanical tiller that's disturbing just the top couple inches of soil. And you know, I'm going to say that that type of disturbance is relatively safe. Okay, so the benefits of no-till and improving soil health. And I just want to say, well, let me just tack back for just a second. How did we get to where we are? Like I said, we haven't used a tiller or any deep plowing since 2017. And now for 2021, for the most part, most of our beds, we just used a rake, and that's it, right before planting. And we just raked in, some amendments, some organic amendments, and maybe some compost. But it didn't happen overnight. The first year we were using a hoe, and we were using the hoe pretty aggressively. The soil was really compacted. We're a production farm. I rely on this income. So you got to do something to get the soil to a place where you can plant. The next year, we used a hula hoe pretty aggressively to kind of like break things up. Hula hoe, stirrup hoe is the other name for that hand tool. And every year my goal was to reduce tool usage. So, okay, we're gonna use this tool. Then next year we're gonna see if we can put that one away and try to use something less and less and less. So that's kind of been our guiding force. So probably the one thing I hear the most when folks visit Blue Raven is, where are the weeds? Like I said, we do have some weeds, but we don't have weed pressure. We have seen incredible decrease in pest and disease. We have seen increased water holding capacity, more so in 2020, the 2021, because of the heat dome and just the never ending heat waves that we got here in the Pacific Northwest. Excuse me. It was a tough year. We've seen decreased labor, and contrary to popular belief, no-till can and is being accomplished on a large scale. Hold on one second. I gotta grab a water. So sorry about that. My throat got dry. Okay, so I think that this pretty much sums up the last 5-6 years. Weeds, pests, and disease were really, really heavy in our first year. And then as of 2021, they are pretty minimal, and the benefits have been substantial. Here's a picture of some carrots in our field. These have never been weeded. You can see the soil structure, and you can see like there's a few little weeds, but very little. And this is pretty much commonplace on our farm, and it's because of lack of tillage. And then just really quickly, our most notable farm improvements, from caring for soil, getting the biology working again, getting that nutrient cycling working again, symphylan losses in 2019, but no loss in 2020. Marmorated stink bugs, significant losses originally, but no losses in 2020 or 2021. And the diamondback moth, pretty much infestation levels in 2017, 18, but very in 19, and no impact in 2020. We did have more pressure this year, and as well as some more aphids, and I have to chalk it up to just stressed plants from drought and heat. So it'll be really interesting to see what happens next year. Disease reduction has been incredible. I kind of can't believe it if I hadn't seen it myself. So we had really significant crop loss, and then a huge reduction to almost none in 2020 and 2021. Weed reduction. Last year, we spent a total of 12 hours weeding the entire 2020 season. So that's 1.5 acres. And this year, we only weeded 8 hours total. That's not a crew, that's like one person equivalent. And then water reduction, significant water holding capacity has been observed. Again, disclaimer, just the incredible heat this year made it pretty tough. So it was definitely a difficult year in terms of irrigation. And there was when it was 114 degrees here, it was I watered in the morning, and by 4 o'clock that afternoon, when it hit 114, the soil just felt so dry. So it was intense circumstances. And then our labor is down 60% from 2018. And a lot of that has to do with just, we're not spending time weeding. And then, so we're just about done. Just a reminder, it can take a few years to get where you want, depending on what your soil type is and what condition it's in. And more than anything, just habits are really hard to break. We are so accustomed as growers to want to be able to see soil that we can, put our arm into and goes up to our elbow. And the reality is that these micropores are really small, the macropores are still really small, and plant roots are really crafty and find a way to get down through there. And then just a reminder, this is all things that have been said all day: planting diversity, organic matter, compost, cover crops, especially multi-species cover crops, leaving crop residues in place. So we never pull plants out by the ground. We always cut at the soil surface, leaving the rhizosphere intact. We do that either with loppers or with a flail mower, and then minimizing soil disturbance as much as we possibly can. Resources, I think we're going to go over these in a little bit. So SARE PDF on organic matter. One of my favorite listens right now is In Search of Soil podcast, 1 to 2 hour, feels like a soil class every episode, and really, really amazing. Gabe Brown's From Dirt to Soil, if you're on a large scale, he's doing 1,000+ acres and no-till. The documentary is Fantastic Fungi, Kiss the Ground, also good watches. And then we do some ecological workshops here at Blue Raven.